Section 15.3 is double integrals in polar coordinates. Remember in, I believe, second semester calculus, we use polar coordinates to what? To kind of make the integration process easier. Sometimes you have some special kind of functions, which if it is converted to polar, it's much easier to deal with and also to take the integral off as opposed to Cartesian in x and y. Just to refresh your memory, remember when we were asked to what graph theta is equal to constant, like let's say pi over 4, the graph is a straight line which makes an angle of pi over 4 with the polar axis, which is the what, x-axis, and it goes through the pole whose components is not 0, 0, but it's 0 comma theta. In other words, there are more than one way to get to a point on the polar coordinates than it was in Cartesian. In Cartesian, this guy is called origin, which was 0, 0, but here it's called 0 theta, so I can what? Select any value of theta as long as what my r is equal to what 0. I happen to be at the pole, so that's why it's called pole, not what origin. And this guy is theta axis, and this guy is what r axis. So this is like when theta is equal to pi over 2. All right. So if r is equal to constant, then the graph is a circle. So theta is equal to constant, the graph is a line. R is equal to constant, the graph is a circle. Like if you would ask me graph R is equal to 2 in polar coordinates, that would be a circle with center is at what? 0, 0 or 0 theta, doesn't matter if you're on the what, X or Cartesian or polar, and radius is 2. However, the problem arises when what? The circle is off-center. What if you ask me to graph this? X minus y squared plus y squared equals 1. Now the center has been shifted 1 unit along the x-axis. So instead of 0, 0, now it's sitting at 1, 0, and the diameter is what? 2. So how would you convert this equation into polar equation? Well, turns out if you go back to the graph of this function right here, you would have this. And if you just zoom in, you get something like this. Notice the cosine of theta is adjacent over hypotenuse. Hypotenuse is what? 2, because that guy is 90 degrees, correct? So what happens is you get r is equal to 2 cosine theta for this, what? Off-center circle whose radius is 1, the center is at 0, 1, 0. So this equation changes into r is equal to 2 cosine theta, and the coefficient of cosine is the diameter of the circle. Do you see it? So that would be a circle which lies along the what? X-axis or the polar axis. If the circle lies along the pi over 2 axis, remember that's pi over 2 axis, then the equation of the circle becomes r is equal to 2 sine theta as opposed to cosine. Do you see it? Remember the usual conversion formulas. X is equal to r cosine theta, y is r sine theta, theta is y over x, r squared is what? X squared plus y squared. R is positive, theta goes from 0 to pi, and theta is measured what? From the positive x-axis counterclockwise. And this is supposed to read 2 pi, sorry. So this is 2 pi, right? So that should be 2 pi, is that right? So now, how do you find the typical element? Remember the typical area element in Cartesian, we decided is dy dx or what? dx dy. So we could go either way as long as we would adjust the limits. What would be that delta A in polar coordinates? Well, in polar coordinates, if instead of rectangular region, if you remember from previous classes, we take a slice of the pizza. So this is called a wedge. So what happens is if you what increase what r radius and what increment angle theta. So delta theta will be theta 2 minus theta 1. So here is theta 1. Here is theta 2. The difference is delta theta right here. And this is, let's say, oh, the graph R1 is equal to some function of theta. And this guy, this curve is R2 is equal to some other function of theta. And their difference is called delta R. So if you take a slice of a pizza from this region, right here between these two, curve, however, not exceeding or going over this angle and that angle. So you're talking about this region only, okay? And portion of it lies here. So you are between these two curves and between these two angles, correct? If you zoom into that slice of pizza, you get this. So this guy is delta R, the increment in the radii, and this is delta theta, the increment in the what? Angles. If you remember from trigonometry class, the arc length S is equal to what? R times theta, provided theta is what? Is in radians. So what happens is this arc length will be R times delta theta. This guy is what? Delta R. So we can approximate this wedge or slice of pizza as if it was a rectangle whose length is delta R and the width is what? R times delta theta. Remember, that's the arc length, correct? So what happens, delta A, the area element, is what? Is length times width. So that would give you delta R times R delta theta. But if delta theta and delta R is small enough, then dA becomes R dr d theta. In other words, the bottom line, the moral of the story is the following. In Cartesian, you have double integral fxy dA, okay, where dA was what? dy dx or dx dy. However, if the function is expressed in terms of r and theta, that means in polar coordinates, okay, guess what? That dA, which used to be dx dy or dy dx, changes into r dr d theta. So this three factors, the product of these three factors forms the area element. Excuse me. Special case, just like before, if this integrand is 1, then this double integral in polar coordinates, then again, it finds the area of this region, correct? So that's called the region of integration. So now I can find the area for you using double integral by letting what? The integrand to be 1. I'm going to show you two examples. One with constant limits, the other one with variable limits. Check this out. Excuse me. Suppose you have a circle. Center is at the 0, 0. Radius is 2. How do you find the area? Well, I don't need calculus 3 to find the area. I know the area is pi r squared. Radius is 2, so the answer is 4 pi units squared. Let's say I want to find the same answer using the double integral in polar coordinates. So remember, the integrand has to be 1. dA gets to be replaced with r dr d theta. And guess what? R never changes, rain or shine, no matter where you take your slice, it always goes from the pole to the circle, which is what? R goes from 0 to 2. And theta goes all the way from 0 to what? Remember, we always go counterclockwise. from 0, which happens to be right here, back to 2 pi, which is the same axis. When you do this, first you take the integral with respect to r, don't worry about the d theta. So that would give you r squared over 2. Evaluate r between 0 and 2, you get 2. Then integrate d theta, you get theta. Evaluate theta between 0 and 2 pi, well, what do you know? You get 4 pi unit square, which we already know that ahead of time. However, if you go back to that off-center circle, then now we have a problem. So r does not go from 0 to 2. Why? Because this is off-center, and you always, what, draw the slice of pizza initiating from the pole. So this should be the tail end, the beginning of the what? Of the slice. It has to be at the pole, and then you extend it. Notice, depending where you take the slice, looks to me r is changing. Sometimes the slice is bigger than the other slice. Sometimes it's smaller. So what that tells you, what? R, the limit for radii, is not constant anymore. Yes, it starts at pole, which is 0, but it's not 2 anymore like previous example. Why? Because now you're hitting this circle, and that the circle has the equation r is equal to what? 2 cosine theta, remember? And on top of it, we have a problem with theta as well. It's not going from 0 to 2 pi, because in the second and the third quadrant, there is no picture. And remember, I'm supposed to go counterclockwise. So it turns out theta goes from negative pi over 2 to pi over 2. So it's very super important to notice the limits of r became variable, and theta is no longer 0 to 2 pi, it's negative pi over 2 to pi over 2. We're from negative 90 to 90. And when you evaluate this, you get r squared, but then you get a cosine that creates cosine squared. How do you integrate cosine squared? I highly recommend that you always use these two identities. If you have cosine squared, replace it with 1 plus cosine 2 theta over 2. If you have sine squared, replace it with 1 minus cosine 2 theta over 2. When you do, you get what? Pi square units. The alternative would have been go from 0 to pi over 2 instead of negative pi over 2 to pi, but due to the symmetry, multiply the answer by what? By 2. So take the double of your answer. Okay, double your answer. And so instead of going from negative pi over 2 to pi over 2, why don't you go from 0 to pi over 2, but double your answer, and you would get the same answer. And that's due to the symmetry. In other words, the graph is symmetric about the polar axis. You can also use polar coordinates to find the volume of a solid. The formula doesn't change. You still got z top minus z bottom times dA. This is the height. This is the area of a typical box. So, and this is still a closed region. The only change is now the dA gets to be replaced with r dr d theta. And the limits of integration, it will be the limits for r and theta. So taking the point home, let's do this problem. Find the volume of the solid, which is bounded by two elliptic paraboloid. One is this guy, which happens to be z is equal to 2 minus x squared minus y squared. Okay. And the other guy is this one, which is z is equal to x squared plus y squared. In other words, we like to find the solid which happens to be bounded by these two surfaces. Notice they didn't even give us any limits, so we have to figure that out. So what you do, you still follow the formula. So it's very super important that I know how the graph looks like, because I gotta know who is on top, who's at the bottom. The top surface is this elliptic, what is this guy, the upside down elliptic paraboloid. So that goes first, and it's important that Z top goes first. Z bottom is this guy. This is the bottom, this is the top. This is the top, this is the bottom. Do you see it? So I gotta know who is on top of who. So, and this would be Z bottom. Now, as far as the limits, notice I don't have the limits for this double integral yet, because what I have to do is what? Find the projection of the surface on xy plane. In other words, find, I should say, the intersection of these two surfaces. All right, find the intersection of these two surfaces. How do I find the intersection of the surfaces? That gives you, that's like setting what? Z1 equal to Z2 and see what the resulting curve is. Okay, remember the intersection. So I should say here, find what? The intersection, sorry about that, intersection of two what? Surfaces, not the projection, intersection. Intersection of two surfaces is a curve. So this is a curve. When you set this surface equal to this surface, you would get x squared plus y squared is equal to a circle. There goes your curve of intersection. This is what I'm talking about when I say the intersection of two surfaces is a curve. Okay, so now here's what else we need to know. So when you perform the subtraction of these two polynomials, you get this. Factor out the 2, you get this. Factor out a minus, you get this. You get 2 times integral over region R, 1 minus x squared plus y squared, correct? dA. You and I, we both know dA gets to be replaced with r dr d theta. X squared plus y squared gets to be replaced with r squared. So you get 2 times 1 minus r squared r dr d theta. So now distribute the r, and you can pull this 2 outside of the integrals because it's constant. And then what? Take the integral with respect to r. So you would get what? R squared over 2, but that 2 wipes out the 2 at the bottom. And then this would give you r, what? To the 4 over 4, but then there's a 2, so it's 1/2, right? But r goes from 0 to 1 because this is a what? Circle center at 0. So r and theta are constant. So r goes from 0 to 1, theta goes from 0 to pi, 2 pi. And you get pi cubic units as the volume of the surface. Warning, we do not start the problem with polar coordinates. We use the polar coordinates, and also, these are some facts, we do not use what? We do not start the problem with polar coordinates. That's fact number 1. Fact number 2 is we use polar coordinates when region is a circular region. When the R is a circular region. Now, one warning, and then that should do it for this section. Warning. When converting to polar coordinates, do not, I repeat, do not convert the limits into polar coordinates. Sometimes when you ask students, hey, can you do this problem in what? Polar coordinates, they go, okay, I'm going to replace this guy with r squared. I'm going to replace that guy with 2r cosine theta. Replace this guy with what? R cosine theta squared. And then keep these guys as 0 to 2. And that is absolutely incorrect. It is not even remotely correct answer. So the way we do this is we, as I said, we graph what? The region. Notice according to this problem, y goes from what? 0 to square root of 2x minus x squared. X goes from what? 0 to 2. So if y goes from 0 to square root of 2x minus x squared and you square both sides of this guy, you get this. And you complete the square, you get this. In other words, it's a circle whose center is at 1, 0, radius 1. So it's that shifted circle in what? In different form, because we are only what? Looking at the upper half. That's why you don't see y squared. You only see y with a plus in front of the radical. So that means you're seeing the upper half. Okay? And x goes from 0 to 2. Of course, that would be what? This right here, which happens to be the diameter. So if you remember, the equation of this guy in what? In polar coordinates was 2 cosine theta. And 2 was the diameter, not the radius. We have to divide this by 2 to get the radius. So turns out if I take my slice of what? Pizza, then again originating from the pole, remember this guy is called pole. Yes, I'm going from 0, but not 2 cosine of theta. And theta goes from here to here, which happens to be 0 to pi over 2. Is that right? So this is the correct way of setting up this limit. Please do not convert these guys to polar coordinates to begin with. Perform the equation, the graph the region, and see for yourself exactly what the limit of r and what theta is in polar coordinates before you just directly change these guys into polar, because that will not be the correct answer. Thank you, guys.